Hey guys, this is Circles Day 8. Today we're going to use what we learned yesterday, finding the area of a circle, and apply it to finding the area of semicircles, quarter circles, and figures made up of semicircles and quarter circles. So let's review really quick. Area is the measure of a figure by how many 1 by 1 unit squares can fit inside it. I know that you're very familiar with area of a rectangle. Yesterday we figured out how to find the area of a circle, and we proved the formula. The mathematical formula to finding the area of a circle is area equals pi times radius, or if it's easier for you to remember, pi r squared. All right, let's take a look at these two semicircles. We'll look at the one on the left first. And so we're going to find the area of these two semicircles. Now, if you remember back to circumference, when we found the area of a semicircle, all we did was multiply our formula by 1/2. And that's what we're going to do here. The only difference is when I find 1/2 of the area, it's going to give me this whole bit inside. Now that might be confusing because when we found half of the circumference, of course it just gave us this part, didn't it? Because it was just half of the distance around the circle. But the area is going to give us the half, or the whole area of the semicircle, okay? So we're going to multiply 1/2 pi times radius, and let's be careful and make sure that we do choose the radius and not the diameter. So I've got it set up so that we're going to find 3.14 is a pi times 6, right? Because I have a diameter of 12, so I have to cut that in half. That's my radius, times 6, and we're going to put that all over 2, right? Because we multiplied 1/2 times all of that. So we'll cross cancel that 2 with one of the 6's, make that a 3, make that a 1 down there, and we end up with area of the semicircle is 56.52 centimeters squared. Okay, let's do the one on the right there. So we have 1/2 area equals half pi times r times r. Our radius is going to be 10, not 20. So let's make sure we choose the right radius. 3.14 times 10 times 10, all divided by 2 or times 1/2. It's the same thing. And we're going to end up with an area of 157 centimeters squared. Okay, let's do the area of a quarter circle now. Now, if we multiply a semicircle by 1/2 to find our area, we're going to multiply a quarter circle by 1/4. Now, let's take a look at this quarter circle. Since this measure right there would be from, if you can imagine this circle complete, you would have another piece right here, and 2 more pieces on the bottom. And this measurement right here would be a radius. So that 2 meters is our radius. So we'll go ahead and substitute that into our formula. And we'll multiply 3.14 times 2 and we'll put all of that over 4. We'll divide that by 4. And we could cross cancel right away, couldn't we? We could make this a 2. We could make this first 2 a 1, and then we could make this a 1, and we could make that second 2 a 1. And we'd end up with 3.14 meters squared as our area for that quarter circle. Okay, pause the video here and go ahead and try that next problem on your own. So this quarter circle right here, or letter B on your notes. Okay, so hopefully you set up something that looks like this, 1/4 pi times radius. And your radius in this case is 10. So we're going to substitute in pi, we're going to substitute in 10, and we've got 3.14 times 10, all divided by 4, and you could cross cancel a couple times right there, and you would end up with 78.5 centimeters squared after doing that math. All right, let's look at this next shape. I'm looking at number 10 in your notes, letter A, and it says, the shaded parts in the following figures are quarter circles. Find the total unshaded area in each figure. And on your notes, so this is a problem, but on your notes, all of these quarter circles are shaded, and the inside is left unshaded. And in my PowerPoint, the inside is shaded. So sorry about that, I didn't notice that, but we are actually going to find the area for all of these quarter circles over here. And it does say find the total unshaded area in each figure on my PowerPoint, but it says shaded area. But anyways, let's correct proceed. Okay, so I've got 4 quarter circles here, don't I? 1, 2, 3, 4. And I'm finding the area of that. And so all I'm going to do is find the area of one whole circle, right? Because 4 quarter circles are going to be the same as one circle. So there's my formula, pi times r times r. My radius is 6. I can tell because I've got a measurement of 12 right here, and that's 2 quarter circles stacked on top of each other. So 3.14 times 6 times 6, and I'm going to end up with an area of 113 400ths centimeters squared. So using what we just did, go ahead and solve letter B, where you're finding the area of the shaded parts in this figure. And I know my shapes of my PowerPoint look funny, but it is what it is. So go ahead and pause the video and then come back and check your work. Alright, well hopefully you noticed that, again, we have a figure made up of 4 quarter circles, and so all I need to do is find the area of one whole circle. I'm already given my radius right here, because I've got a little arrow here that shows that from the top of the quarter circle to the bottom is 3 meters. So I'm going to plug that into my formula as my radius. Area equals pi times 3 times 3. And once I do that math, I'm going to come up with 28.26 meters squared. Now we've got a fun one. So this is a figure made up of several shapes. We've got a semicircle, we've got a rectangle, and a triangle. And I just taught you how to find the area of a semicircle. You already know how to find the area of a rectangle, and hopefully you remember how to find the area of a triangle. So just thinking of a plan here, what we're going to do is we're going to find the area of all 3 of these shapes, and then we're going to add them together. Why don't you pause the video and see if you can do that on your own before I tell you how to do it. And then just come back and check your work. Alright, well let's go ahead and find the area of the rectangle first. We know that the area of a rectangle equals length times width. I'm going to substitute in my values. Here's my length, 50 meters. My width is right here, so 20 meters. And 50 times 20 is going to equal 1,000 meters squared. Now let's solve for the area of the semicircle. The area of the semicircle equals 1/2 pi times radius. Where's my radius, by the way? Let's see. I'm looking at this side. This side of the semicircle is a diameter, right? So that diameter is equal to this measurement right here, which is 20 meters, which means that my radius will be half of that, or 10 meters. So we'll substitute in our values, 3.14 times 10 times 10, divide all that by 2 or multiply by 1/2, and we're going to get the radius of our semicircle is 157 meters squared. Okay, now, you may or may not have remembered that the area of a triangle can be found by multiplying 1/2 times base times height. So we'll substitute in our values 1/2 times 12 times 20, and we're going to get 120 meters squared. Now that we know the area of all 3 of those funny shapes, we can add them all together, and we'll get 1,277 meters squared for the total area of our figure. Alright, now we have a figure with 2 semicircles, and we want to find the area of the shaded part in terms of pi. So go ahead and pause the video. I think that you can do this on your own again, and come back and check your work. Alright, first we're going to solve for the big semicircle. So just thinking through this problem, if I want to find the area of this shaded part, I'm going to need to find the whole area of this large semicircle, and then I'm going to need to subtract the small semicircle from it. So I guess we're starting with the small one. That's what I've got up there. So we'll start with the small one, and I've got my formula, and I'm substituting in my values. Now my radius is 1. These arrows show that the diameter of the small circle is 2, so I want to cut that in half and write 1 for my radius. Multiply that by pi and divide by 2. So my area of the small semicircle is going to equal 1/2 pi centimeters squared. Remember, I'm keeping in terms of pi here, so I'm not worried about actually multiplying pi times 1/2. Now we'll do the large semicircle. So we have pi times radius divided by 2. And the radius of my large semicircle, of course, is going to be 2, right? Because you've got 2 here and 2 here. So that's my radius. So I can cross cancel right here. Cross cancel out 2, make it 1, make that guy a 1. And I'm left with the area of my large semicircle is 2 pi. Now I'm going to subtract my small semicircle from my large semicircle. So I'm going to subtract 1/2 from 2. Since both of these areas are in terms of pi, I can subtract one from the other. So 2 pi minus 1/2 pi is going to equal 1.5 pi centimeters squared. And that's it for this lesson. Hopefully this was helpful to you, and I hope you have a great afternoon.